I am Anil Kumar. Welcome to your YouTube channel. Here we have requests from you for which we provide solutions. Here is an excellent question based on geometric sequence. We'll also review what a sequence is, what is a geometric sequence, and answer related questions which will strengthen your understanding of this topic. So we have a sequence given to us with numbers 3, 6, 12, 24, 48, which is a geometric sequence, and we need to answer the six questions based on this. We need to define it, verify it, find some terms, define a formula, and then figure out if a given number is on the sequence or not. So let's begin with understanding of geometric sequence. The sequence given to us is 3, 6, 12, 24, 48. What you notice here is that the ratio of consecutive terms, the terms which come together, 6 and 3, for example, if I divide 6 by 3, I get 2, right? Similarly, if I divide 12 by 6, what do I get? If I divide 24 by 12, what do I get? And also 48 by 12, 24. So for each, we have a constant ratio. So this ratio, which is 2 in this case, is normally designated by letter R, and the ratio is 2 for the given geometric sequence. Now each 3, 6, 12 number in the sequence is called the term number, and 3 is the value of first term. 6 is the value of the second term, right? So now I think you've understood. Now, with this information, let us now define geometric sequence in terms of first term. So the first term here is 3, and the ratio of consecutive terms, which we figure out as 2. So I think you can put it in words that in a geometric sequence, every term has a constant ratio with its previous terms. So the ratio of consecutive terms in a geometric sequence is a constant which we normally designate by letter R. Now part B and C is verify that T2 is indeed 2 times T1, T3 is 2 times the previous one, so that we can always verify. So T2, which is 6 for us, so let's do what is 2 times 3. So 2 times 3 is 6. So we have verified that second term is twice the first. Similarly, you can verify the others. Now, part C is find the seventh term. Now, to find the seventh term, there are two methods. One, we need to figure out a general formula, or we could just expand this particular sequence. So I prefer to expand first, right? So we'll have 3, 6, 12, 24, 40, 48, right? Okay. So this is your term number 1, this is 2, this is 3, this is 4, 5, 6, and 7. So we need to just double them to get the next two terms. So 48 times 2 is 96, right? So 96 times 2 will be 6 times 2 is 12, and then 1, 192. Clear. So the seventh term, which is written as T subscript 7, is 192. Is that clear to you? So that was easy. Now, think about it. If I tell you to find the 100th term, what will you do? Can you go up to 100 terms? No. We should get the general formula, right? So that is what we are going to take up now. So in a geometric sequence, how do we derive a formula? So, so part D is derive the general term Tn, means nth term, in terms of Tn minus 1. Well, that's simple. So Tn in terms of Tn minus 1 will be R times Tn minus 1. Correct. So in this case, this is called recursive formula. But with this formula, we should know the previous term to get the next term. So what we are going to do actually here is, well, figure out what is the general formula. General formula we'll find in terms of T1, the first term, and R, the ratio. Since the first term and the ratio actually defines the complete geometric series, right? So now let's try to understand that in general, if I had, or we can go with this example also. So we had this term 3, 6, 12, 24, 48. So you can see that the first term T1 is basically equal to 3. And T2, as we know, is 2 times 3, right? So 2 times 3. T3 is 2 times 2 times 3, right? Since we multiplied the previous term. So this 2 times 2 times 3 can also be written as 2 square times 3, right? So 2 is the ratio, right? So in this case, we know T1 is 3 and the ratio is 2. Now, how about 24? Let's look into 24. 24, which is the fourth term, right, will be 2 times T3, which is 2 square times 3. So I could write this as 2 cube times 3. Now you see, powers of 2 are 1 less than the powers of the term number. So from here, we can actually derive the formula that Tn equals to r to the power of n minus 1 times T1. Makes sense. So the number which multiplies to T1 is r to the power of n minus 1. In general, we write this formula where the first term is written first, right? So we'll write Tn equals to T1 times r to the power of n minus 1. Makes sense? So that becomes our general term. So with the help of the example we derived at a result, you could also take a general example and then derive it. So let's go for that also. So here we got this formula Tn equals to T1 into r to the power of n minus 1. So in general, what we could have is that we have the first term as T1, the second will be r times T1, correct? Third will be again you have to multiply r square times T1, and then will be r cube times T1. So like this, the nth term will be what? R to the power of n minus 1 times T1, right? If you are writing R first. But in general, as I said, we normally write the term number first, right? Okay, great. Now, we can use this formula, which is Tn is T1 r to the power of n minus 1. Says find the 10th term from your formula, right? So let's find the 10th term, means Tn. So Tn will be T1 times r to the power of 10 minus 1. Clear? So it may be good to write the term which you're multiplying with in brackets. So let's do that. So T1 is given to us as equal to 3 in this case, right? So T1 here is equal to 3 and R is equal to 2. So we have within the bracket 2 to the power of 10 minus 1, which is 9. Okay, great. You can use the calculator and find the result. I'll give you a tip here. 2 to the power of 10 is kilobytes, written as 1024. So 2 to the power of 9 is going to be what? Half of this, right? Going backwards, divide by 2 means 512. So I could write this as 3 times 512. Makes sense? So now I can write the 10th term as 3 times 512. So 6, 3, 15. So that becomes the answer for this particular question. So I hope you have understood the strategy, how to use this formula effectively. Perfect. And how to derive it. You could write it either way. Nth term is the first term times r to the power of n minus 1, or you could write the opposite way because multiplication is commutative, right? Now, let's take the next question, which is in this given geometric sequence, which is 3, 6, 12, 24, 48, and we now know the formula Tn is T1 into r to the power of n minus 1. Check if 3072 is a term value for this sequence. So that's what we need to check. So let's begin with the given formula, which is Tn is T1 into r to the power of, I prefer to write brackets here, n minus 1. Now we know T1 is given to us as 3, r we found ratio of 2. Here we are looking for a term 3072. So we'll write 3072 for the nth term. The first term is 3 for us, r is 2 for us, right. So dividing 3072 by 3, we should get 2 to the power of n minus 1. And that is 1024, which is 2 to the power of n minus 1. Correct. Now I think you can get the answer. Sometimes a calculator may be required to do such questions. But this one, fortunately, we can do without calculator since we know that 2 to the power of 10 is 1024, right? Now, in this case, we know this is 2 to the power of n minus 1. That means n minus 1 is 10, or n is equal to 10 plus 1, or n is equals to 11. So the 11th term is basically equal to 3072 in this geometric sequence. Makes sense. So, see, we have done so many questions related to geometric sequence with a given example and understood the whole concept behind it. I hope you find this interesting and useful. Extend this knowledge to answer many other questions based on geometric sequence. Thanks for your valuable time and all the best.